Okay, so ladies and gentlemen, welcome to 45, maybe 55, if not too much, of number of the minutes for the topic of taking your in-memory and operational analytics application to Azure SQLDB. As Jason already mentioned, my name is Niko Neugebauer. Here is all possible information about myself. I describe myself as a Microsoft data platform professional, and that means that I actually like to work with the data platform that Microsoft creates for everybody, and all the rest of the stuff you can check out. The only thing I will mention is that I really like the Columnstore Indexes, and I do extensively blog about them, and you will find here the link to my blog. All right, so without further ado, let's move on to the real content. And our agenda today consists of a small number of points. Basically, I want to spend some time making sure that people understand what is the in-memory thing. I want to make sure that we at least understand some of the basics of the column store indexes. I want to talk what was the last idea about the operational analytics from Microsoft, and since the original session, as we were planning with Jason, Microsoft has officially changed the term of operational analytics to HTAP, meaning hybrid transactional analytical processing. This is not just the term that Microsoft is using. It's a popular term that most of the database vendors and analytic companies are using to describe the workloads that are really hybrid, mixed ones. I will talk some basics about the Azure SQLDB, just making sure that we are all on the same note, and by that we will be almost finished, hopefully, with the introduction. I want to mention something that happened in the last 3 months. This something is called SQL Server 2016 Service Pack 1, because we can definitely identify the time you were working with SQL Server and Azure SQLDB before the Service Pack 1 for 2016 and after. And we will see how these news will and are affecting the current state of the in-memory and column store, and of course of the operational analytics. And I want to focus just a couple of seconds to the migration part, how you migrate to Azure SQLDB currently. And we will finish on a high note, considering the positive aspect, the advantages of using Azure SQLDB, because I will naturally, maybe because I do it quite naturally, I will be bashing some of the aspects of the Azure SQLDB, so don't get worried. There are more than enough positive things about it, and you should consider definitely using it. All right. So if you have any questions, as Jason mentioned, just drop them. Just raise your hand and wave a flag. So a couple of words about the memory optimized feature of the SQL Server, which is also known as a hackathon for the most of the people. So what is this in-memory engine? This is nothing extraordinary per se. That it's not something new outside of the engine of the SQL Server or Azure SQLDB. This is not like the R services in SQL Server 2016, which are running in parallel and to SQL Server, and they're just connected. No, it's an integrated part of the SQL Server engine. I'm trying to use the in-memory or memory optimized terms for the engine, even though Microsoft for 2014 especially started promoting it as an in-memory OLTP, which I think is badly wrong, because there are huge use cases of those in-memory tables for the ETL processes, so you can use them, and you should use them for data warehousing for BI. So the main goal of this engine, of this sub-engine of the SQL Server, is to get 100-time improvements. I mean, if they will get more than 100 times, I don't think somebody will be unhappy, but the idea was they took the word hackathon from the Greek, and it sounds similar to hackathon, and it means 100 in Greek, meaning to make it 100 times faster. It's fully ACID compliant. There is nothing groundbreaking. If you're running a transactional processing, so OLTP operations, you will be at home. There are no changes. You might ask, well, wait a second, you're talking about all these funny or not so funny things, and I mean, the database is in memory. Is it consistent? Is it persisted? Well, for the in-memory tables, you can configure if the data is stored definitely, persisted on the disk, or it is just used temporarily, so-called schema-only table. But you can say, wait, but I have, I don't know, 4 terabytes of RAM and my database is just 100 gigs. Well, sure thing. Your database might be in memory, but it's not optimized. It's not tuned to be worked directly only with the memory part. And this is what one of the biggest advantages of this memory optimized or in-memory engine. Okay, the basis is optimistic multi-version concurrency control, which you should know if you're a SQL Server professional. If not, you will need to research and read some papers. I can recommend very highly a book from Kellen Delaney on the hackathon, on the in-memory, where she goes in a very deep details in explaining all the functionals, all the basics, and all the deep stuff about the MVCC. All right. So what about those memory optimized tables? Microsoft worked for a number of years on them, and they, after the research did their part, they patented the technology in 2009, and in 2014 there was a first working version of the in-memory functionality. If you didn't look at the SQL Server 2014 and working with it, or if you consider that the in-memory is useless, take a good look, because take a good look at what Joost de Bruijn, the program manager of the in-memory feature, has written, and the examples of it. And besides the first initial release, it's been vastly improved for 2016 version and for the Azure SQLDatabase. So the idea is that on the right side you can see the whole stack of the time spent on a typical query processing for OLTP. And the idea was basically to cut the latches, the locking, and the interpretation of the execution plan. So the idea was, let's optimize 90%. Let's make it smaller or throw it completely away. And this is what was done. So I mentioned this already. So all of the works are really optimized for the memory operations. No latches, no locks, so it's really fully optimistic concurrency, which will require you, of course, to write some error handling. Compiled request to native code. You can create natively compiled store procedures in 2014, and in 2016, and in Azure SQL Database, you can go as far as creating memory optimized triggers, functions, and so on. So all the improvements of 2016, they are already in Azure SQL Database, of course, because Microsoft develops for Azure SQL Database first. If you want to try the new features, you should be running Azure SQL Database, at least in the research. wanted to mention the interop is when we write a normal, non-compiled, non-precompiled T-SQL query, which I will be showing at the end. And it can touch on the in-memory tables and join them with the traditional disk-based tables. And you can also create the natively compiled store procedures. You will be limited of accessing only on the in-memory tables, but it is called as a faster option. And I don't have a slide on this, but just write it down. Just remember it. In the current version of the SQL Server 2016 and Azure SQLDatabase, the natively compiled store procedures, they are limited with a lot of things. The most important one of that the max DOP, so the number of cores processing assigned to the will be limited to 1 core, meaning if you have 16 cores, you will not be using them if you go with the natively compiled store procedures. So interop for the analytical queries, this is where you want to be, not in the natively compiled store procedures. All right, so in-memory part, I will just skip this part because I see I spend a lot of time and I want to get to the real purpose of this presentation. I listed a lot of stuff here. Since I will be giving the slides, you can read them later. You can send me a tweet and ask me for clarification if you don't understand something. Most important part, you can see the the biggest screaming limitation of 2014 that were lifted in 2016. And if you have some limitation with 2016 and looking to migrate to Azure SQLDatabase, I suggest you that you will scroll through all of the features of the news in Azure SQLDatabase and in sorry, just need to turn off the notification since they turned on with a new day and I have a midnight right now. So when you migrate into Azure SQLDatabase, take a look at the news. Take a look at what is new in the vNext versions. And right now, as in the moment of this presentation, we already have the 1.1 version of the CTP for the SQL Server vNext, so the version right after the SQL Server 2016. And you will be able to test those features, and maybe your application will have the advantage of taking these and using these features before they will appear on premises. Ah, I'm getting old. Don't pay too much attention to my English, please. All right. Okay. So all of these limitations and the fact that, of course, the memory used by the in-memory tables is something that they will fight for. And when I will be showing you the example of the practical code on Azure SQLDatabase, I will mention something, because even if I am using P6 database, there are some sizes limitation, as obvious, for the amount of the memory used by the memory optimized tables. And you need to be aware of that, because if you don't, you will not be able to migrate your application successfully to Azure SQLDatabase. So watch out, monitor the memory. There are more than enough scripts for that. All right. So what about the column store? Columnstore, you should have heard about them, one thing or two. They exist in the SQL Server world. since 2012, and they are vastly improved with every edition of SQL Server. And I can tell you that in Azure SQLDatabase, if you will use it, you will be using the next version, definitely. So some of the upcoming features in the next version of the SQL Server, like the support for the lobs, for the clustered column store, is already available in Azure SQLDatabase. But what are actually the column store indexes? The column store indexes are the indexes, the type of indexes which is very well suited for the massive data processing. I will use the overloaded term big data just because I can. So the column store indexes, they are vertically separated. They internally grouped into the segments and the row groups around 1 million rows at a time, and they're extremely compressed. So if you're using the compression for the column store indexes, you will get times better than any page compression you will be using. So very fast, has usage advantages as long as you are using large volumes of data. Meaning, if you have like 500 rows, please don't use the column store. Like, no sense at all. All right. There were some, you know, hacks to be used in 2014, and there are some ways, a couple at least in 2016, but it's not for the general public, not for everyone. So the difference between the traditional storage or the traditional indexes, which I call the row store, and the column store is following. If we have a table with 4 rows and 4 columns, if you ask the non-IT people and say, do you know how this database is storing the values? They will say, yeah, probably like in columns. These values will be stored together. The values from the second column, the third, the fourth, they will be stored together. Well, as all of you definitely should know, the traditional indexes until the column store, they were storing the values from the same row, from the same register, together. So if we would have a clustered index on this table, we would have all of the values stored together. The column store, they store, as I at least believe, they store the data as the non-IT people believe the indexes are storing the data. The advantage is that the values of the same column, they are repetitive, they are similar, and they will be much better compressed. So you will definitely have the repetitions unless you're doing the sequence or doing identity, and huge advantages really. So what happens when we create a column store index? We do the row group separation, we create the segments, and we do the compression. So imagine the same 4 columns table with around 4 million rows. One of the first things that the index creation process will do after it finished with the global dictionary building and the sampling, it will create those row groups. For 4 million rows, in the best case, we will have these 4 horizontal row groups. Then we will definitely split all of the columns from each other, and we will create the meta connections between the values of each column and that belongs to the same row group. And the values for one specific column, for one specific row group, they are called column segment. That's the terminology. And another very important thing I always try to mention is, but when we are compressing the data, it's if we run the rebuild, and you should not be running the rebuild operation on your operational analytics because of a number of reasons. First of which is not the automated reordering, but because the rebuild operation on the column store indexes is an offline operation. Imagine you have 100 million rows table and you want to run a rebuild. Well, if you're running 24/7 shop, there will be no transactions on your table. I'm sorry to give you the bad news. All right, so to explain the advantages of the column store, let's run a simple query. Let's run this query of summing C2 and C3 values of some table and having a predicate for C2 that the values should be between 10 and 20. So do we need a C1? Well, not really. Do we need a C2? Yes. We are counting on it. We need to filter the values. C3, yes, indeed. And C4, well, it's not in the query. So before we start even processing the query, the meta information will tell, well, 50% of the space occupied the column store, not needed. All right, we won't touch on those segments. They can stay on the disk, or they can still stay in memory for the in-memory column store, but we will definitely win on I/O, on memory processing. The funny part is that the most of the data types, and this information is documented, they support the storing of the minimum and the maximum values stored within this segment. And so for C2 we have this sequence, which has some small overlapping, 10 to 20, 15 to 30. These values overlap. It's quite normal. Just don't worry about this. There is no sorting currently in the Columnstore indexes. They are never ordered. So do we need the first row group? Well, I don't think so. Do we need the second row group? Yes, because we are looking for the values between 10 and 20. That's correct. 15 to 30? Yeah, there should be some values. For them. And so we will eliminate them. The Columnstore indexes, they have a huge advantage, so they eliminate the segments automatically in the background. You don't need to think about it too much. You can optimize for these, but that's a different story. And so you see in this example, I will process just 25%, just 4 segments instead of 16. That's how beautiful the Columnstore indexes are. So the biggest limitation for the non-clustered column store in 2012 and 2014, they were non-updatable. They could not be used for any operational analytics. They were just basically very useful in 2014 for the cases where you are trying to do some reporting analytics on stable tables that you are using for the data warehousing, BI, or reporting. Because you add the data to the non-clustered column store indexes through partition switching, but you will not do this on OLTP type of the operations. In 2014, the clustered column store started allowing the storage and updated updates and inserts and deletes on the data. This is the basic architecture of this solution. I'm leaving this since it would take us another hour to go through all of this. You just have the slides and you can research or send me a question on this. So let's dive finally by the half hour into the operational analytics. What is the operational analytics? And what is this hybrid transactional analytical processing? So analytics, what is it about? What kind of analytics do we have? It's a popular word. For me personally, it's kind of a buzzword because there is predictive, prescriptive, business analytics, machine learning, data mining, all of this stuff. There is OLAP, or there was.
Hey, Niko, your microphone cut out.
It's because I'm tossing too much. And so there is a big data. Is it better?
Yes. Yep.
Jason?
Sounds good.
Okay. Thank you. So there is a big data all of this world, but you know, technically it goes all down to the only thing we treasure the most, which is the data. All right. And this is the traditional HTAP architecture. Of course, it's not HTAP, it's not hybrid transactional analytical processing, but this is what all of us, the BI people, did or do or will be doing in a lot of cases. So we have the presentation layer, we have this all, including the SQL Server, the presentation layer application tier with EES, and the SQL Server with the database. This is all an OLTP application. Then we have the ETL process, which is running hourly, daily, weekly, monthly, whatever, which is running most of the time in the background or nightly process, extracting the data and integrating it within the relational data warehouse. Naturally should be based in SQL Server, where we will build some cubes and reporting based on analysis services. It's quite a complex implementation traditionally with a lot of problems. I will list some of them, like costs. You will not run this on the same virtual machine most of the time. Oh, well, at least in my beliefs, you shouldn't. And if you're running it in a different machine, you will have to pay for the licenses and analysis services license, you know, which is part of the SQL Server. But if you go enterprise, like the Columnstore Indexes and InMemory, yes, still enterprise features before the Service Pack 1 of the 2016. Excuse me. Let me just check if my sound's still okay. Can you hear me still, Jason?
Yep. Can still hear you.
Okay. Then there is a problem, not only the costs. There is also a problem with breaking the ETL. I know it never happened to any one of you, but sometimes the developer of application, they change the data type or they change something and the ETL process goes broken for a couple of days or weeks and nobody cares. So, and the BI analyst is starting to complain with all the rights because he doesn't get the updated information. And then there is a delay. You don't see the real-time information, and everybody just going crazy. Everybody wants to go as real-time as possible. So people try to do directly querying the application database, and with the traditional indexes, well, it's very problematic. You will get a huge logs. It's performing slow. It doesn't give you a good result. So what happens with this hybrid transactional analytical processing? In other words, cutting all the crap, we got the updatable non-clustered column store indexes for the disk-based tables. And before I will dive on this, I just want to make a very clear note. Please, no matter what the other people say, test your workloads before going full speed on HTAP and throwing your cubes and your relational data warehouse away. Nothing, absolutely nothing substitute analytical query performance when the schemas are really customized and optimized. Because having 20 or 50 tables, small ones, huge execution plans, most of the time will deliver very distinct and different performance from a denormalized and optimized query, star or snowflakes schema. Okay, so operational analytics in 2016 and beyond, we have two types. The operational analytics for the raw store, for the disk-based tables, and for the in-memory tables. Okay, so this means you can have your in-memory table and you can build an updatable column store index for the in-memory. Architecture pictures, don't get scared. You know, no time for this. Just want to warn you, and this is, I don't have any like forbidden or NDA information that I will share, but it's my core belief that with every version the solution will be going different ways in some directions, because we have here the traditional part, the compressed row groups, the deleted bitmap, one or multiple delta stores. We have here the B tree, the traditional disk-based index, and we have a new structure, deleted buffer. This is for the updatable non-clustered column store. For clustered column store, we have a different structure for different purposes. And for in-memory tables, we have another different structure, which does similar thing, but there is it stores different type of information. There is no deleted bitmap. It's just, you need to study this stuff in order to understand it better. Just a warning. And this is an example that every time you see a column store index scan, you should think about column store index scan as a rather complicated multiple join execution plan. This is not the full thing that happens underneath, but it will work. It will do a lot of operation. Okay. All right. So as a next step, let's talk about the Azure SQL database. So Azure SQL Database is actually what Microsoft is really developing, because they don't develop the SQL Server. SQL Server is a snapshot, which is reconfigured version of the Azure SQL Database. So the bleeding edge is the Azure SQL Database, and you can get the newest features for the money you are paying in the background, and Microsoft will take care of this. And it's an amazing solution which has some obvious limitations right now, but by the time most probably you are watching this recording, a lot of the information I will be showing will be already gone. It will not be available anymore, in the sense that it will be upgraded. The numbers are different. So before taking a decision for migrating any of these applications, basic column store or in-memory or disk-based operational analytics, take a look at the current numbers, and I will provide you the links at the slides where you can find those. Okay, so data platform Continuum from Microsoft, you can see how you can start, and this is the idea, that you start with a physical raw iron SQL Server and you move slowly or fastly into the direction of the platform as a service, where Microsoft will be managing all the infrastructure and the high availability of the Azure SQL database. From my side, I can tell you that the clients, my company where I work for, we help to migrate to even to the virtual machines. Once they understand what this Azure SQL database is, they want to move to the managed solution, because it gives them overall much less headaches and less administration costs. So another thing is very important to mention. Some of the intelligent capabilities that the Microsoft Azure SQL database has. Some of them, like query performance insight, threat detection, and index advisor, you will not have on premises, because on premises you do not have additional services that Microsoft is using for that. Like Microsoft is using Azure ML to give you some of the advices on the threats, or some of the suggestions for the new indexes. This is one of the huge reasons you should consider Azure SQL database. And before I will dive into some technical numbers, I want to explain what those numbers should mean. There is something that is called database throughput unit, or in short terms, DTU. What is a DTU? DTU is a mixture of 4 parameters: the reads, the writes, the CPU, and the memory. You can see them here on the right side. So DTU is the maximum value out of one of the 4 parameters. So if you spend 75% of your assigned read, your DTU will be 75% spent. And what is exactly DTU is something that Microsoft will not go in the detail, because maybe and most probably they will be changing it over the time. But what I have seen of the evolution of the Azure SQL database, it's not because they're bad, but most of the time you will see free upgrades. So Microsoft will give you something free, and this DTU is a relative measure of how to how the different instances are correlated. If you want to make sure your application runs well on Azure SQL database, you need to do a good testing on that. And there is no other way how you can avoid this. You can start maybe with the standard instance if you are not using any of the advanced features, and going further you will move to the premium ones. The big advantage here is that the scale up. You can scale up and scale down the Azure SQL database. There is something that bothers me right now, which is that with the changes of the Service Pack 1, you should be able to get some of the other features here, which is still not here, but in a couple of minutes I will mention them. The number of the DTUs, you can scale them, and this is basically the relative numbers. Sorry, some things just jump up here. And you can scale them from a relatively small number of DTU performance of P1. You can go right now to P15, which gives you an incredible number. So you can expect that P2 is a double, gives you double of the performance of the P1, and so on and so forth. So this is just a small table here of the operations and the indexes. So I had no time to dive into the different types of the in-memory indexes that exist, but if you are deciding which operational analytics solution you are running, if you're running the disk-based, you can have all of the typical operations on your indexes. And if you're going for the in-memory with obvious advantages, that you are avoiding touching on the disk for reading, and you will be doing much less logging and disk impact when you are persisting information, here are the limitations. So if you're using the hash index, you will not be able to do some of these operations. These are some of the Azure SQL database notes I wanted to provide to you. So before you start migrating, bear in mind
Niko, your volume cut out again.
Let's bring it up to a reasonable number.
Yep, you're back.
So thank you. So your latency will be different. It doesn't mean it will be worse. It might be much better, but it will be different. Like with any data center, you need to test it. So on Azure SQLDB, you have some programming surface limitations. They're very minor. Mostly that the DMVs will not work right now, and I hope by the time you will be watching the recording, it will be solved. The the CLR are right now are disabled. The cross-databases queries, the global temporary tables, these things will not be available right now, but you will have a lot of advantages. So, for example, you will have three replicas of the same database, and they will be patched and managed on the background, and you don't have to worry about this. Okay? So, let's take a look for the reasons to migrate to the InMemory to the Azure SQL database. One of the things you need to bear in mind, these are all of the current premium instances, and these numbers are the hardwired cap for the InMemory tables. It means that if you are migrating to P1, you will not be able to hold more than 1 gigabyte for the cache store for the user cache store of the in-memory tables, which means, oh, you're running a 64 gigabytes on premises or in VM SQL Server instance locally, and you are using 10 gigabytes for your in-memory tables. Well, breaking news, you will need to migrate to P11 at least in order to keep on doing what you're currently doing. This is one of the key limitations that people forget about when they try to do this migration, and I hope that this number, and I honestly believe they will change soon, hopefully very soon, and they will be growing over the time, but this is like, don't go to in-memory if these numbers are too low for your application. Another limitation is the overall size of the database. If you have 5 terabytes database, or you have over a terabyte database, you need to consider maybe it will not fit into your P15. But stay tuned. Microsoft is definitely working on providing great upgrades and some crazy numbers. And by the time you're watching this recording, hopefully it will be already, you know, a couple of terabytes will be nothing to worry about. The other limitations before starting to consider the migration to in-memory operational analytics is following. The number of workers, it's less worrying than the max concurrent logins. If you have
Niko, your microphone cut out again.
If you have a database that is accessed by thousands of users, logins in parallel, you know, you need to pick up the right instance for that. And that will, of course, will reflect the costs. So what happened in the around 1 month ago? There was a SQL Server, which is badly written, Service Pack 1 on the 19th of November, I believe. So the news were creator outer, user hints, clone database, fast memory, optimized Columnstore Index edition. So very good feature actually. Detailed information in the execution plans, and so on and so forth. But the most important thing was this, the programming surface, the features. Microsoft made an incredible effort of making all of the enterprise programming features available for almost every edition. The only limitation are those where it's simply impossible to do it right now or at all. So like in memory, you can have it on standard, on web, on express. You just can't have in memory on the local DB because, well, the access rights will simply not allow you to do in a local DB. And even though the size for the in-memory is limited to typically 1 1/4, so 25% of the buffer pool size of the instance. So for the standard edition of the 2016, we have a cap for the buffer pool for 128 gigabytes. You can run a database with InMemory which is occupying up to 32 gigabytes. Well, that's a huge number, right? Because if we scroll back to the size, you can run the P15 on a standard edition of the Azure SQL, of the SQL Server, and you cannot have it right now on Azure SQLDatabase. I'm absolutely sure that it's just a matter of a couple of months when Microsoft will port these features into Azure SQLDatabase. But right now, you can go to standard and you can have operational analytics running there. You can have the column store with InMemory, or you can have the column store with a disk-based table with partitioning, with a polybase, all of these. Really great. So this one has changed in the last 3 months, and I would claim it changes the reason of migration to the Azure SQL database. Stay tuned. I really believe Microsoft will change it soon. So what about the migration? How do you migrate to Azure SQLDB? So you can use the Management Studio to extract the backpack and to migrate your database. You can extract the backpack with the portal, with the PowerShell, and put it into a new database on Azure SQL Server. You can use the SAMW, this is a migration wizard, or you can use the data.
Niko, your microphone cut out again.
No, it's not. I'm sorry. I will be trying to correct this. You can use the Azure Data Factory to migrate the data. Also, it happens, and you can use the transactional replication. And this is the preferred way for migrating online. So this is fully supported, already for 1.5 years available. You can put your database and migrate it to InMemory. What is the smallest problem if you're migrating in-memory operational analytics? In-memory transactional replication is not supported. Right now, you can only do the transactional replication of the disk-based SQL database. This is documented, and I hope that very soon it will be fixed. But if you are running 24/7 shop and you are looking to migrate online without any downtime to Azure SQLDB, you will need to use the disk-based tables first. So you will need to remove the in-memory tables. You will need to do the transactional replication to Azure SQL database, and then you will need to migrate the data from the disk-based table to in-memory tables. All right? And you can use another way I learned a couple of months ago. Some very smart people even use the linked server from on-premises to Azure SQLDB to migrate the schema and the data. Very, very interesting. A couple of slides, you can watch them later since we're getting close to the end. Too slow. And the advantages of the Azure SQL database are these. So you automated patching, the high availability, you don't need to care about this, the disaster recovery. Well, if you need a manual disaster recovery, you can go as far as 1 month beyond on a granular basis and restore the version of the database that you are using. And of course, the exclusive features that will be appearing only in the next SQL Server version, and plus exclusive features that are really cloud-based, like index suggestion that are using Azure ML on the background. And before finishing it and testing your patience, I just wanted to show you the scripts, a simple script. I'm running here on the P6 instance in my CCI test database. I'm running here a version of the AdventureWorks, an upgraded one, which I did with the help of Atom Mechanics Make Big AdventureWorks script, which will be provided in the links. So I dropped the database for the in-memory operational analytics. I created a table and I put some 20 million rows. And as you should know, for compressing the data, we will basically need to extract the object ID and use very uncomical store procedure which will migrate the data from the tail row group into the compressed segments. And I already have pre-executed the queries. I ran these 3 similar queries on the disk-based table on with the disk-based indexes, ignoring the updatable non-clustered column store. I ran the same query on the non-clustered column store on their operational analytics, and I ran on in-memory table. I just want to provide you with the execution time. So in the first disk-based table would take me almost 23 seconds, and the operational analytics would take me just 4 seconds. Huge difference, huge advantage. And this is the in-memory operational analytics times. This is just 240 milliseconds. But I have to confess, I managed to put only 20 million rows. I tried to put 100 million rows, but I went over the limit I have shown before in my understanding. So here, let me just show you again. So I went over 8 gigabytes of in-memory table and I was just cut out. The Azure SQL database told me, well, you need to calm down. You can't have it all. So the idea is to give you the overview and to give you the some kind of the basic indication of the way how you can migrate the data from on-premises or on virtual machine or SQL Server in VM to Azure SQL database. And I would say thank you very much for your attention, and I would like to find out if there are any questions.
Yeah, Niko, we've got 3 questions here. What do you think the future of traditional OLAP systems will be with the coming of HTAP?
Very good question. Traditional BI system will persist very much because they are not, you have a one database and you running the insight on some operational database. Data warehousing, a serious data warehousing implies, one version of truth. It will not change. You need a separate place where you will be storing the information and analyzing it. And as I mentioned before, and I want to show you this slide again, just making sure that you really understand this. Where is it? Because it's almost 1 a.m. and my brain starts to shut down. This one. Nothing substitutes the analytical query performance. So Microsoft knows this very well from their 2016 experience, that the operational analytics is not the solution for everything and for everyone. And I really hope that there will be done something about this for the future. So I think this is just an acceleration. You can run some basic reporting, but the data warehousing BI, they don't go anywhere. They can't.
Sounds good. So the next question is do you think Azure SQLDB will overtake AWS market share in a short time?
I would hope so. I don't think so. in the short term, but I think once these changes I have shown you, with the service pack 1, with the programming surface, once we will have all of the column store, the in-memory on the standard edition, well, if I would be working on a.
Looks like you might have lost your volume again.
You're right. I'm so sorry for that. I have high hopes for 2017 for what Microsoft is cooking, for their preparing, and I really believe that once they will port the Service Pack 1 features into Azure SQL Database, and it's not trivial because you need to balance all of the engine stuff in order not to, to hurt performance of any other noisy neighbors. Once it will be functioning, I think it will be more than exciting, and it will start hitting quite hard on the AWS.
All right, and then the last question, another question we have here is, how does the analytics work with Elastic Azure SQLDB?
So Azure Elastic SQLDB is basically a conjunction, Elastic DB or pool, just to make sure that I understand the question.
It just says Elastic SQLDB.
So I just have on the top of my head the Elastic database pool, which is basically an aggregation of different databases. And on the database level, this is just another feature. Operational analytics is just another feature. So if you can run SQL query, then it will work.
All right. And then last question here is ETL layer going away for real-time data warehousing?
I will answer, that's a very good question, and I will answer like this. There will be
Nico, your microphone went down again.
Keep this and making sure that it's not dropping down. So if for the operational reporting, and this is the key word, it's going away. If you want to do the reporting, the basic stuff like counts, distinct counts, which stuff Columnstore or basic aggregation that Columnstore does brilliantly, this one for ETL is going away. But for the real-time data warehousing, it can't go away because data warehousing is the one version of truth. You can't have the whole truth in just one operational database. You have more and more different distinct sources. So you need to integrate them somewhere. So no, this part I believe will be actually getting bigger and bigger and bigger.
All right, sounds good. That is all the questions that we have. So with that, I'm going to wrap up tonight's session. And I thank everyone for coming out tonight. And I hope everyone got as much out of this session as I did. So thanks again, Niko.
You're welcome. Thank you very much for your attention.